Hello everyone. So today we will see the first chapter of class 12, that is relation and functions in mathematics, and we will cover the NCERT portion for basic classes. So let's begin. So I assume that you have studied earlier the basic definitions of sets and relations and functions, and this is like forward of all these chapters or concepts of that. So you will see the other things also, that types of relations and what are the functions. So yeah, let's start. So what you have learned there, that what is the Cartesian product. So I will first start with the Cartesian product. Okay. So suppose that we have an element of set A that is equal to A comma B, and I have another set B which has elements 1 comma 2. So if I just find out A cross B, what will be that? That will be equal to the product of the elements of A to B. So it will form a set of ordered pairs. First will be A comma 1, then A comma 2, separated with comma. Then we will multiply B with 1 comma 2. So what will be that? B comma 1 and B comma 2. So this is what? This is the Cartesian product of A and B. Now what is relation? Relation is a subset of this. Relation is a subset of this A cross B. So if I have a relation like A comma 1 comma A comma 2, so this is a subset of A cross B, and it is one relation which is formed from A cross B. So this is the basic definition of relation, that it is a subset of Cartesian product of any two like sets, and it can be on a single set also. If you have a relation on A itself, if a relation is relation on A itself, on A, then I will compute A cross A there. Like if I have A cross A comma B, and I will multiply it with A comma B again, and that elements on order pair which I have formed here, that will contain a relation like a product. A Cartesian product will be there. Cartesian product A cross A, and the subset of that will be relation on A. Okay. So this is the basic definition of relation. Now we will proceed with some examples here in NCERT which is given. So I will basically cover the NCERT portion. That is why I have fully focused on the NCERT for the students which are not getting this properly. So this will be helpful for them, that basic points of NCERT will be covered here, which are important. Okay. So suppose that I have a set of students of class 12, which is denoted as set A, and I have another set B of students of class 11th of same school. Then some of the examples of relation from set A to B are. So here it is given that there are some relations from A to B. If I have A comma B element, that is A from capital A and small b from capital B set. So if A is brother of B, this is one relation, because it is written in a, like you can say that it is related written in a set builder form, and I have given the definition for set A cross B, and it is a one type of relation on A cross B. Okay. Similarly, for another relation A comma B where A is sister of B. So this is another type of relation on A cross B. Okay, these all relations are what? The subset of A cross B, which I have told you previously that relation is a subset of any Cartesian product of two sets. Similarly, there is another type of relation where A comma B, age of A is greater than age of B. This is another example of relation on A cross B. Fourth one is also a relation, that is total marks obtained by A in the final examination is less than the total marks obtained by B in the final examination. So we are changing the condition in each example, and this example is just showing us a connectivity or a rule of something that is called a relation. So relation is, we can say that any rule which connects two elements of two sets. Okay, so yeah, let's proceed to the next slide. So now we will learn what are the types of relations. So we will see that how many relations are there in the NCERT portion, and we will try to explore them. Okay, so yeah, suppose that there is a relation on set A itself. Okay, like this is I have already told you that A cross A is the Cartesian product of any set on itself. So there is an empty set phi and A cross A that are extreme relations. Okay, so it has some like subset. One is phi and another is A cross A. So this subset is what? This any subset of A cross A is the relation also. So this relation is what? Empty relation on A cross A. And this is what? Universal relation on A cross A. So what is the difference between them? The phi is the relation which contains zero element or zero ordered pairs of A cross A. And in universal relation A cross A, all the ordered pairs are there present in the relation. Okay, so we will see one example for that so you can understand properly. Like I have, for example, on set A, the relation is given, and set A is given as 1, comma 2, comma 3, comma 4 elements. The relation is given as A, comma B, where A minus B is equal to 10. So this is an empty set. Why? Because see, I have A set which is 1, comma 2, comma 3, comma 4. And I have to find out A, comma B, like if I have A minus B is equal to 10. So can you find any two elements in this that have the difference equal to 10? If you suppose write 1, comma 3, okay? Yeah. If you find 1, comma 3 here, so whether the difference between 3 minus 1 is equal to 2, is it equal to 10? No, it is not equal to 10. So I cannot find any pair of elements on A itself. Like if I do here A cross A, and I will see that I can find out A cross A, like if A cross A is here, uh, like 1, comma 1, and it will contain 1, comma 2 also, 1, comma 3, 1, comma 4. Yeah. So I cannot find any ordered pair which has the difference equal to 10. So this is what? This is a null relation. Null relation. This is an example of null relation here. Or you can say empty set is there, so empty relation is there. And if I define another relation R dash, which is given here in your book, but R dash equal to A comma B, where a minus b is greater than equal to 0. Mod of a minus b is greater than equal to 0. Okay. So it will be what? See, here you have like a cross a. In a cross a, you have uh, 1 comma 1 is also there, 1 comma 2 is there, 1 comma 3 is there, 1 comma 4 is there, and so on. You have 2 comma 1 is there, 2 comma 2 is there. So basically you have elements, order pairs of elements, and if you take any, like I will take any ordered pair 1 comma 1, so mod of 1 minus 1, which is equal to 0, is greater than equal to 0. Yes, it is satisfying because 0 is equal to 0. So that is why this will contain the first element, first order pair, sorry. And similarly, it will contain this order pair also, because 1 minus 2, that is equal to 1 minus 2, and its mod will always give you positive output. So 1 minus 2 is what? Minus 1, and its mod is 1. It is greater than equal to 0. Yes, it is greater than equal to 0. It also is present inside the relation. So I can see here that this relation is what? The universal relation. Okay. So the R dash is here universal relation. So this example is given in your NCERT. To just to clarify the difference between empty relation and universal relation. Okay. So I hope that you got the point of empty relation and universal relation. So the definitions are written here. A relation R in a set A is called empty relation if no element of A is related to any element of A. That is, R is equal to phi, and it is a subset of A cross A. Similarly, for universal relation, a relation R in a set A is called universal relation if each element of A is related to every element of A. That is, it is the R is here A cross A. So both the empty relation and universal relation are sometimes called what? Trivial relations also. Okay. So yeah, we will proceed now further. So now we will see another example of, or another type of relation, which is like you can say that it is not given in your NCERT, but I will tell you that it is identity relation. So I will clarify what is it. First of all, I have to rub this part which I have drawn here. Yeah. So now we will see that what are the next types of relations. First, I have told you that the one type is identity relation. Okay. So what is identity relation? Identity. Suppose that I have a relation. I have a relation like this. R is given as order pair of 1 comma 1, then 2 comma 2, and 3 comma 3. Okay. So each element is related to itself only in this relation, and that is why it is called identity relation. No other type of elements or order pairs are there. Only the order pairs are which are related to itself only, like 1 comma 1, 2 comma 2, 3 comma 3, and 4 comma 4, 5 comma 5, so on. We can add on it, but other than this, like we cannot have 1 comma 2 here or 2 comma 3 here. So this is what identity relation. Okay. So yeah, now we will see one type, that is equivalence relation. But before that, we have to check that what are the conditions or what are the types of relations to satisfy and being called as equivalence relation. Okay. So first of all, I should remove this part which I have drawn here. Then we will see what is equivalence relation and what are the reflexive symmetricity and transitive condition for that. Okay. Yeah. So see here, reflexive relation. Yeah. If reflexive is what? If I have like relation R is there and I have 1 comma 1 is there, 1 comma 2 is there, then 2 comma 2 is also there. So I have the pair of like 1 comma 1 and 2 comma 2 also there, and it is containing only 1 comma 2 elements in this reflective relation. Like 1 and 2 are only the elements present here, and the pair 1 comma 1 and 2 comma 2 is also there. Like the relation is containing the relationship between the two ordered pairs itself. Like 1 comma 1 is related to 1 itself here, and 2 is also related to 2 itself here in this relation. Other than that, all other elements can also, or other ordered pairs can also be present. Like 1 comma 2 is also present, so I can have here 2 comma 1 also there. So this is the basic difference between identity relation and reflective relation. That in identity relation you must have only 1 comma 1, 2 comma 2, 3 comma 3, only these type of ordered pairs, not like 1 comma 2, 2 comma 1. But you can have in reflective relation 1 comma 2, 2 comma 1 also in the relation. Okay, so this is one difference between a reflexive and identity relation. So I hope that you got the point. What is the reflective relation? Reflective relation means that if a comma a is also present in the relation R for every a belonging to R, or you can say A for every a belonging to capital A. Okay, so it means that if I have relation R on set A, means A cross A is the product, Cartesian product, and I have relation R on that. So if for each A belonging to capital A, means that each element belonging to set A, I have the uh, A comma A present inside the relation, then it is called reflective relation. Yeah. Okay. Now I will tell you that what is symmetric relation. We have just now seen what are the identity relations and reflective relation. Now I will tell you what is symmetric relation on set A itself. Okay. So yeah, suppose that in relation R on set A, okay, I have the uh, elements in A. Suppose are one. A is the set. A is the set. I have element like 1 comma 2 comma 3 here. Okay. So if R is a relation on set A which contains 1 comma 2, then it must contain 2 comma 1 also there. Like if I have 1 comma 2, then 2 comma 1 should be there. Should be there? No, must be there. And then if I have like 2 comma 3 is there, so I must have be 3 comma 2 also there in the relation R. So this is the necessary condition for symmetric relationship, that if 1 comma 2 is there, like if I have A comma B in the relation R, so this means that I should have B comma A also in the relation. Okay, so this is the condition for symmetricity. So I can generally write this relation like symmetricity definition. I can write if A comma B belong to R implies B comma A must belong to R for all A comma B belonging to capital A. This is the definition of symmetricity of any relation. Okay. So we have seen the uh, three types: identity relation, reflective relation, symmetricity relation, or symmetric relation. But for equivalence relation, you should have only three type of conditions of relationship that must be satisfied. First is reflexive, second is symmetricity, and third is transitive nature of relation, which I will tell you just now in the session. Okay. So yeah, first I will use this. So what is transitive relation? Suppose that if I have a relation R on set A, okay, and if I have A comma B belonging to R, yeah, and B comma C belonging to R, then it must be there that A comma C also belong to R. Yeah. So these all like order pairs should be present inside the relation R. If A is related to B, B is related to C, then A should be related to C also in the relation R. So this is the condition of transitivity of any relation R. Okay. And here like A comma B comma C belong to capital A. Means these all A comma B comma C elements should be there in the set A. Okay. I will tell you an example of this. Like if I have A set which is contain 1 comma 2 comma 3 elements, and suppose I have a relation capital R which is given as 1 comma 2. The relation R is on set A itself. So 1 comma 2 is the element order paired element in this, and then I have 2 comma 3 there in the relation, and the third order pair I have like 1 comma 3 there in the relation. Okay. So you can see here that 1 is related to 2 is related to 3, and then 1 is related to 3 also. So 1 is related to 3 also present here. So what it will call? It will call transitive relation, because A related to B, B related to C, and then A related to C also present inside this relation. So what we can say here, students, that it is a transitive relation. Okay. So if all the three conditions of this relation are satisfying, like if the relation is reflexive also and symmetric also and transitive also, then the relation is called an equivalent relation. Yeah. So we will now see some examples of equivalence relation and try to solve these examples given in the NCERT. So let's proceed. And I hope that you all have got the point of what are the types of relation in the NCERT given portion, and what is the definition of relation. So let's see some examples of relation, then we will proceed further. Yeah. So example is given as, let T be the set of all triangles in a plane with R a relation in T given by R is equal to T1 comma T2, where T1 is congruent to T2. Show that R is an equivalence relation. So what is given in the question? The capital T is the set of all triangles in the plane with R a relation in T. R is a relation given in the T, where R is it is the statement is it contains the ordered pair T1 comma T2, where T1 is congruent to T2. That it is two types of triangles T1 comma T2, and T1 is congruent to T2. We have to show that this R is an equivalence relation. So I will explain it in visual manner. Suppose that I have a plane, and here I have many types of triangles are there. Like it has some like equilateral. It will contain equilateral triangle also, scalene triangle also, and right triangle and isosceles triangle. Many type of these scalene triangles and isosceles, all types are there in the plane. So if I have one triangle which is I have to show that it is related to itself also. So is the triangle is congruent to itself? Yes. If I put this triangle here and I copy and paste here this triangle again, then it must congruent to itself also. So it shows that the relation R is here. R is here what? Reflexive. Because T1 T1 are also present. T1 comma T1 order pair is also present inside the relation R. Every triangle is related to itself also. So this statement of R is reflexive is true. Yeah. Now we will see that whether the relation R is symmetric also or not. So if I have suppose one triangle and the other triangle is there, and you suppose that it is congruent to this by SAS rule. So if one is congruent to SAS rule with second, so it should be 100% true that 2 is also congruent to A by 1 by SAS rule only. SAS rule only. Okay. So this rule is satisfying here that if 1 is related to 2, then 2 is also related to 1 by the same criteria. That is, if 1 is congruent to 2, 2 is also congruent to 1. So it shows that if T1 comma T2 T1 comma T2 belongs to R, this implies that T2 comma T1 also belongs to R. Yeah, this implies that R is symmetric also. R is symmetric relation also. Okay. So we have just now proved that the relation R on set of triangles is a reflexive and transitive, reflexive and symmetric both. And now I have to prove that is it transitive or not. Okay. So if T1, T2 and T2, T3 belong to R, so T1 is congruent to T2 and T2 is congruent to T3. So it must, like if I have T1, this triangle is T1 and it is related congruent to T2, means it is related to T2. And by congruency rule, you can say that suppose that SSS is the criteria of congruency to T2 and T2 is congruent to T3. Okay. It is also congruent to T3. So if it is congruent to T3, then you can see that these are congruent. So it must 100% be true that T1 is congruent to T3 also. Why? Because T1 is congruent to T2 and T2 is congruent to T3. So it must satisfy that the T3, like the shape of T3 triangle is also congruent to T1. So we can say that T1 comma T2 belongs to R T2 comma T3 belongs to R, this implies that T1 comma T3 is also belonging to R. Okay. So the relation is R is also transitive here. So we can say that the relation is equivalence relation. Here R is an equivalence relation. So we have shown that this is a equivalence relation. Okay. So just now we have seen this example of NCERT that the set of triangles and their congruency is a equivalence relation. We will now see one another example of NCERT, which is the example third here. This is also a good example. Let us try to solve this. Okay. I will erase the remaining portion. Yeah. So in example 3, it is telling that let L be the set of all lines in a plane and R be the relation in L, defined as R is equal to L1 comma L2 and L1 is perpendicular to L2. Show that R is symmetric but neither refractive nor transitive. So we have to prove here that it is a symmetric relation but not refractive and not transitive. Okay, it is a very good question. Let's solve this question. Yeah. So we will take the lines and we will draw the lines and try to make sure that what are the relations that we are followed here. Okay. So let L1 is a line. This is L1 line. Here it is shown here that L1 is a line. Okay, and L2 is a perpendicular line to L1. So L1 comma L2 should be present here. Okay, L1 comma L2 is present here, and L2, if L1 is perpendicular to L2, then it must be true that L2 is also perpendicular to L1. You can see from the figure also that if L1 is perpendicular to L2 here, so L2 must be perpendicular to L1 also. So this tell us that L1 comma L2 belongs to capital R. This implies that L2 comma L1 also belongs to R. So we can see that this relation is R is symmetric here. Okay. So it is telling in that question itself that R is symmetric. Yes, R is symmetric here. But it is neither reflexive nor transitive. Yeah. So if I have L1 comma L1 belonging to R, then it is a reflexive. So if a line L1 is here and I will tell that it is perpendicular to itself, it is 100% false. Why? Because L1 and L1 I will paste here, then it must not be perpendicular to itself. It can be parallel or anti-parallel, we can say, or it is coincident to the L1, but it cannot be the perpendicular relationship between L1 and L1. So L1 comma L1 does not belong to R. Thus, relation R is not reflexive. It is clearly shown here that it is not a reflexive relation. Now we will see that whether it is a transitive or not. So suppose I have this line here. You can see in the figure that L1 is the line is there, and L2 is another line is there, which is perpendicular to L1, and L2 related to L3 also. That is L3 and L2 are perpendicular to itself. So can we say that L1 is perpendicular to L3 also? No, these are not perpendicular. These are parallel to each other. You can see the figure. L3 is here parallel to L1. So the relation is not, R is not transitive also. Okay, because L1 comma L2 belongs to capital R and L2 comma L3 belongs to capital R, but L1 comma L3 doesn't belong to capital R. You can see here L1 and L3 don't belong to this, does not belong to capital R. Okay, so I have shown here that R is not transitive as well as not a reflexive relation, but it is a symmetric relationship. Okay, so till now we have learned about what is relation, what is the Cartesian product of two sets, and how to represent the relation. And yeah, so these all points are covered in the NCERT. I have only taught you regarding the NCERT portion, and we will cover the JE portion also in the upcoming lectures. First of all, we will cover the NCERT portion and also try to solve the questions of NCERT exercises and make sure that we will complete it in as early as possible. So yeah, let's move forward. I will erase this part and then we will see the next subtopic, that what is the next thing we have to learn. So here one example is also of that equivalence relation. You can do it by yourself also, that a comma b 2 divides a minus b. Okay, try to solve this question, and if you have any doubt you can comment and we will try to answer this. Okay, so we will move further and see that what is the next thing here we have to try to learn. Okay, we will see one another example, that is example 6, and try to solve it in a as early as possible manner and see that what are the conditions that are telling in this question. Okay, so yeah, let's start. It is given in the question that let R be the relation defined on the set A that is containing the elements 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7. By R is a relation where A comma B, both A and B are either odd or even. Show that R is an equivalence relation. Further, show that all the elements of the subset 1 comma 3 comma 5 comma 10 are related to each other, and all the elements of the subset 2 comma 4 comma 6 are related to each other, but no element of the subset 1 comma 3 comma 5 7 is related to any element of the subset 2 comma 4 comma 6. Yeah, so let us try to solve this question. Given any element A in capital A, both A and A must be either odd or even. Okay, so what is it is telling here in the question that uh, I have to show that that relation on in the set A comma B, both A and B are either odd or even. Okay, Yeah. So if I form, is if I have the like set A, which is given here 1 comma 2 comma 3 comma 4 5 6 7. Okay. So if R is a relation on this set A, where A comma B, both A and B are either odd or even. So R is the relation here. Okay. R is the relation given on this set A comma B, both A and B are either odd or even. Both A, B are either odd or even. Okay. So what are the what is the relation R? How we can form this relation? So try to draw the what are the elements are there, or what are the ordered pair in the relation capital R. Okay. So I will draw here what are the relations. So R can be of 1 comma 3. Here both A and B are odd. Okay. And it can also have 1 comma 5 there, 1 comma 7 there. Here all the 1 comma 3 order pair has both elements are odd, and in 1 comma 5 both elements are odd. Similarly in the 1 comma 7 both elements are odd. And if I try to pair any even digit number, so if I take 2 here, then I should must or here will take 4 or 6, because these are only the even numbers inside this set. So 2 comma 6 should be there. So like this I have the relation R. Okay. Oh yeah. So we have to prove that R is an equivalence relation. So yeah, if I have 1 comma 3 in the relation, then I have 1 comma 1 also in the relation, and 1 comma 1 is there. So what it is a uh, one element of type of reflexive. So I have 5 comma 5 also there, and 7 comma 7 also there in this relation R, because it is defined on set A only. So on set A, if the relation is defined, so I have the elements of type 1 comma 1, 5 comma 5, 7 comma 7 also present inside this relation. Also I have 2 comma 2 also in there in the relation. 4 comma 4 is also there, and 6 comma 6 also there. So I have all the ordered pair of A comma A type belonging to capital R, where A belongs to capital A. So what is this? This is the definition of your yeah, reflexive relation. Okay. So you can say that the relation is what? Reflexive relation. Now I have to show that it is whether it is transitive or symmetric also. Transitive and symmetric also I have to show there. Okay. Yeah. So I will rub the this part, and we'll show that whether it is symmetric or not. Also I have to show that whether it is transitive or not. I have shown here that it is a reflexive. So one part is over here and two parts are remaining. So yeah, if I have like 1 comma 3 there, so I must have 3 comma 1 also there. Yeah, it is true. And if I have 1 comma 5 there, then I have 5 comma 1 also there, because both are odd also. 1 comma 5 is also odd, 5 comma 1 is also odd. If I have 2 comma 4 here, then I must have 4 comma 2 also here in the relation R. Okay. And if I have 2 comma 6 there, then I have 6 comma 2 also there. So on, I have got all the A comma B there. This implies that B comma A is also there inside the relation R for every A comma B belongs to capital, and like if it is a set, then it belongs to A set. So yes, this is what the statement for symmetric relation. So this relation is also symmetric relation. Okay. Till now we have got that the relation is reflexive also and it is symmetric also. Now we will see that whether it is transitive or not. Okay. So I will erase this part and then try to prove that whether it is uh, transitive or not. Yeah. So if I have in this relation R, if I have 1 comma 3 is there and then I have 3 comma 5 there. So I must have 1 comma 5 also there, because 1 is also odd and 3 is also odd. So 1 comma 3 ordered pair is inside this relation R, because I have must have the pair of their odd numbers or the pair of uh, the two even numbers of the set A. So 1 comma 3 is present there and 3 comma 5 is also present here. This implies that 1 comma 5 is also present inside this relation capital R. Why? Because 1 and 5 are also odd numbers and this relation must contain 1 comma 5 also inside this relation. So this relation is something like, if I have 2 comma 4 there, I've shown for odd numbers one example for odd, and I will show now even like even ordered pair. 2 comma 4 is there, and if I have 2 comma 6 is there inside this, like 2 comma 4 is there and 4 comma 6 is there, so I must have 2 comma 6 also related to this relation. Okay. So I can see here that if A comma B belongs to capital R, this implies that if B comma C also uh, belongs to R, so it must satisfy that A comma C must also be belonging to capital R, and where A comma B comma C belongs to capital A. So it is what I have already told you. This is the statement for transitive nature of any relation. So I have shown here that the relation R is reflexive also, symmetric also, and transitive also. So I can also say that R is equivalence relation, because all the three relationship conditions should be satisfied for equivalence relation. Yeah. So yeah, for this I have just proved that the relation R is equivalence relation. Then the second part is telling that what are see here what is the second part of this question is telling. Show that all the elements of the subset 1, comma 3, comma 5, comma 7 are related to each other, and all the elements of the subset 2, comma 4, comma 6 are related to each other, but no elements of set is related to element of set subset, but no element of subset 1, comma 3, comma 5, comma 7 is related to any element of subset 2, comma 4, comma 6. It is obvious that this statement is obvious because we have the like 1 comma 3 comma 7 is the subset which is containing only your odd digits, and the other subset that is 2 comma 4 comma 6 is containing only even digits. So there is no connection between 1 comma 3 comma 5 comma 7 relation subset to 2 comma 4 comma 6 subset, and that is why the all the two relations are not related to each other. Okay, like elements of 1 comma 3 comma 5 comma 7 are not related to elements of 2 comma 4 comma 6. Yeah, because these are odd and these are even. Okay, and also it is telling that if 1 comma 3 comma 5 comma 7 all the elements are related to each other. Yeah, all are the elements related to each other because in the relation we have seen that 1 comma 3 is present there, 3 comma 5 is also there, 1 comma 7 is also there, and so on. All the elements of these are like odd, and the ordered pair of these must be present in the relation capital R. So these all are related to each other. It is 100% true. And for the other part, that is 2 comma 4 comma 6, these are also related to each other because these all are even numbers, and we can form the like ordered pair of even numbers 2 comma 4, 4 comma 6, and these will be present inside the relation R. Okay, because these are all even numbers. So this is the solution for this question. It is lengthy one, and I hope that you got this question, and we will see the other part of this chapter, and also try to uh, solve the exercise of this in the next lecture. And if you have any doubt or any like you have to take private sessions from us, you can tell in the chat box or you can contact us. And if you have other types of queries or doubts inside your mind, you can also comment in the chat box. Okay, so for today this is all the lecture, and these all things are done for the today session. We will see the next class in the next session. Till now I will wrap up the session. Thank you and goodbye.